बिस्मिल्लाहिर्रहमानिर्रहीम सल्लल्लाहु अलैहि वआलिहि वसल्लम अल्लाहुम्मा रब्बि ज़िदनी इल्मा सल्लल्लाहु अलैहि वआलिहि वसल्लम आमीन अल्हम्दुलिल्लाहि रब्बिल आलमीन. In this lecture, I will discuss some important questions of AP and GP. An important advice: be serious. These are some important formulae of AP. This is the nth term formula of AP. It's a plus n minus 1 times t. This is the last term formula. This is the sum of n terms, n upon 2 bracket 2a plus n minus 1 times d. This is the Sn formula of AP in terms of the last term. When we have three consecutive terms, then we can find d in this way: t2 minus t1, t3 minus t2. We use this formula to make the calculations easy. This is the nth term formula in terms of Sn. For example, if we need T2 and if we have S2 and S1, then we can get T2 in this way: S2 minus S1. T2 S2 minus S1. These two numbers are same, and this number is 1 less than this number. This is the structure of AP. A plus D, A plus 2D, A plus 3D, and so on. See, this coefficient of D is 1 less than the term number. If we have 4 here, then this should be 3. So if we need T10, then it should be A plus 9D. GP. This is the nth term formula of GP. This is the Sn formula: A times bracket 1 minus r to the power n over 1 minus r. This is the sum to infinite formula, and remember, sum to infinite only exists when r lies between these two values, minus 1 and 1, exclusive. And when r lies between these two values, then the GP is known as converge GP. For three consecutive terms, use this formula of r to make the calculation simple. This is the structure of GP. And the power of r is 1 less than the term number. So if we need T10, then it should be a r power 9. Well, time is inclusive in both AP and GPs. For example, if the first year is 2005 and the last year is 2015, then for this n is 1 and for this n is 11. Because if you will count on your fingertips from 5 to 15 years, then it should be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 11 years. So years or months or days, both in AP and GP are inclusive. This is the index of this worksheet. Question number 1. The 12th term of an AP is 17. So this means T12 is 17. So A plus 11D is 17. And the sum of the first 31st terms, first 31st term means S31, is 1023. Find the 31st term. The question is find T31st. And it should be A plus 30D. And for this we need A and D. So by solving these two equations simultaneously, we can get the values of A and D. So after getting the values of A and D, we can find this T31st. And the values of A and D are, D is 4, whereas A is minus 27. Hence, this is 93. Question number 2. The sum of the first and second terms of a GP is 50. So T1 plus T2 is 50. And the sum of the second and third terms is 30. So T2 plus T3 is 30. So T1 is A and T2 is AR. So by taking A common, we have 1 plus R is 50. T2 is AR and T3 is AR square. So by taking AR common, we have 1 plus R, 30. So I'm shifting this R on the other side to make this substitution simple. See, this and this both are same, so we can equate their right hand sides. So 50 is equal to 30 upon R. Hence R is 3 upon 5. And the question is find the sum to infinity. For that we must have the first term. So with the help of this equation, we can get the first term. 1 plus 3 upon 5 is equal to 50. Hence, the first term is 125 upon 4. Now we can get the sum to infinity. 125 upon 4, 1 minus 3 upon 5, and the answer is 625 upon 8. It's better to leave the answer as a fraction. So this was question number 2. Next question, number 3. A cyclist completes a long distance charity event across Africa. The total distance is 3050. So this is SN. He starts the event on May 1st and cycles 200 km on that day. So this is A. On each subsequent day, he reduces the distance by 5 kilometers. So that means a decreasing AP. So on the first day 200, on the second day 195 because D is minus 5 and A is 200. Now the question is how far will he travel on May 15th? So this is the indicated term. Whenever indicated term is required, so you always use TN formula. A specific term, a particular term or indicated term means TN. So in the first part we need T15. It should be A plus 14D. Since A is 200 and D is minus 5, therefore T15 is 130, I guess. So that's the answer of A part 1. Now we need N. On what day will he finish the event? So we need N. And for that we will use Sn because Sn is given 3050. So N upon 2, 2A, A is 200, N minus 1, D is negative 5 is equal to 3050. Well, when you will solve this equation, you will get two values of D, N, 20 or 61. Since both values are positive, so we have to verify our answer. And we can easily verify our answer by finding T. So T20 and T61. So when you will find T20, you will get 105. And when you will find T is 61, you will get minus 105. And the cyclist needs to complete this distance. So if he is going in this direction, so you must go in this direction. So this answer means he is going in this direction. And this answer means he is going in the opposite direction, which is not possible. Hence, n is equal to 20 is the right answer. And this is the rejected answer. Now the next part of this question, part B. A GP is such that the third term is 8 times the sixth term. This is simple. T third is 8 times T6. And the sum of the first 6 is this. Find the first term and sum to infinite. So 3 part B. Given that T3 is 8 times T6. T3 means AR square, whereas T6 means AR power 5. So by cancelling A and powers of R, we have 1 is equal to 8R cube. So R cube is 1 upon 8, therefore R is 1 upon 2. Now we need A. For that we can use sum of the first 6 terms, which is given 31.5. We are using this equation for the value of A. So it should be A 1 minus R, R is 0.5 to the power 6 over 1 minus 0.5. Hence A is 16. Now we can get the sum to infinite. B part 2. 3B part 2. Sum to infinite is 16 upon 1 minus 0.5, which is 32. So this was question number 3. Next question, question number 4. I will not solve first part completely. I will just explain the first part. 4a. 2 convergent. Convergent means sum to infinite exists. S infinite exists. P and Q have the same sum to infinite. So it's given 2 sequences P and Q both have same sum to infinite. And the first 2 terms of P are 6 and 6R. So the R of P should be 6R upon 6, which is R. And the first 2 terms of Q are 12 and minus 12R. So the R of Q would be minus 12R upon plus 12, so minus R. Find the value of the common sum to infinity. So S infinity of both are same. So the first term of sequence P is 6 upon 1 minus R, and the first term of this sequence is Q. So 1 plus R, and its common ratio is minus R, so 1 plus R. The common ratio of P is R, so 1 minus R. So when you will solve these two, when you solve this equation, you will get the value of R, which is 1 upon 3. And now you can easily get sum to infinite. 6 minus 1 minus 1 upon 3, which is 9. Now the next part of this question. The first term of an AP is cos theta and the second term is this, and theta lies in this. The sum of the first 13 terms is 52. Find the possible values of theta. So first we need D. This is 4 part B. So D is T2 minus T1. And T2 of this question is cos theta plus sine square theta. And T1 is cos theta. So D is sine square theta. Now we have to use this given information. S13 is 52. So 13 upon 2, 2a, a is cos theta, 12d, d is sine square theta, is equal to 52. So you have to replace this by cos square theta. This is 4, and when you will shift to on other side, this is 8. 2 cos theta. Now substitute sine square theta by 1 minus cos square theta to factorize this equation easily. So the simplified form of this equation is 6 cos square theta minus cos theta minus 2. When you will break the middle term, you will get these two values of cos theta. Make sure you will mention the breaking of middle term. Now this is in first quadrant and this is in second quadrant. So in first quadrant the answer is cos inverse 2 upon 3, which is 0.841. And in second quadrant, find alpha first. This is alpha. Cos inverse half. It's cos 30 is pi by 3. I don't have calculator right now, so you will check this value yourself. I'm not writing this value here, I'm just writing the answer. The answer is pi minus alpha. You can do this yourself. So there are two possible answers because of the given domain. The domain was 0 to pi. So two possible answers. Hence, theta is 0.841 and the second answer, this one. This question is of differentiation. I mean AP with differentiation, AP-GP with differentiation. The function f is defined by part 1, find f prime x. So fx is 4x plus 1 power 3 upon 2. So when you will differentiate this, you will get 3 upon 2 coefficient, 4x plus 1, subtract this power by 1, so half, and the differential of this bracket is 4. Hence the simplified form of this would be 6 times under root. This is f prime x. Now we need f double prime x, which is very simple. We can differentiate under root as 1 upon 2 under root 4x plus 1, and the differential of function is 4. This is, I think, 12 upon 4x plus 1 under root. So part 1 is done. Now the next part. The first, second and third terms of a GP are this and this. So we need F2, F prime 2, F double prime 2 first. So F of 2. Part 2. So F of 2 is 4 into 2 plus 1 power 3 upon 2. This is 27. F prime 2. This is 18. F double prime 2 is 12 upon 9, 4. So R is T2 upon T1 and T3 upon T2. So T2 is F prime 2, which is 18, and T1 is 27. T3 is KF prime 2, F double prime 2. This is T3. So the value of this is 4K because F double prime 2 is 4. So 4K over 18. So K is 3. And this is what we had to find. You can check this solution again. Question number 6. Part A. An AP has first term this, fifth term this, and last term is this. Find the sum of all the terms. I will not solve this question completely. I will just explain the concepts. So, first term is 32. Fifth term is 22. Fifth term means A plus 4D. So, you can easily get the value of D from here because we have A. And the last term is minus 28. So with the help of last term, we can get the value of n. A plus n minus 1d. We have A, we have d, we can get n. So n is 25. D is minus 2.5. N is 25, so we need sum of all terms. All terms means S25, and S25 would be 50. Part B. To save time, I'm not solving questions completely. Part B is, each year a school allocates a sum of money for the library. The amount allocated each year increased by 2.5%. So this is GP with R 102.5%. In 2005, this is the first year, and the first term is 2000. Find the total amount allocated in the years this to this inclusive. So these are 10 years. So we need S10 with R 102.5%. This is 6 part B. So A is 2000, R is 2.5% increase, so 102.5, which is 1.025, and N is 10, and we need S10. So 2000, 1 minus 1.25 power 10 over 1 minus 1.025. So when you will solve this, you will get 22406.76, but you have to leave your answer up to 3 significant figures. So 22400 dollars. Next question. The first two terms of an AP are this and this. Find the least number of terms, that is n, exceeds 20,000. Exceeds means Sn greater than 20,000. So we can have D, which is 8. So Sn upon n upon 2 is 16, n minus 1, D is 8, greater than 20,000. So when you will solve this, you will get two values of n. You will get n 69.2 or n minus 72.2. Negative value is invalid, and you will get this inequality when you will simplify this one. Remember, you have done this in O levels quadratics. When we have greater sign, we write answers in this way. Smaller value here, larger value here. Hence the answer is 70, the least possible value of n. The next part of this question. A GP has the first term 6 and the sum to infinity is 18. A new GP is formed by squaring each of the terms. Squaring means you just need to square the term, a square and r square to get the first term and common ratio of the new GP. So 6 and 18, we need sum to infinity of the new progression. So this is very simple. This is 7 part B, I think. So A is 6 and sum to infinite is 18. So with the help of sum to infinite, we can get R. 6 upon 1 minus R is 18. So R is 2 upon 3. For the new GP, you just need to square A of the previous GP and square R for the ratio of new GP. So it's 4 upon 9. And we need sum of infinite of the new GP. So 36, 1 minus 4 upon 9, which is 64.8. It's better to leave the answer in fractional form. So I'm leaving this for you. Do it yourself. This part is very important. 8. The common ratio of a GP is R. The first term is this, and sum to infinite is S. Show that S is 2 minus R. So this is very simple. S infinite is denoted by S. And the formula of S infinite is A upon 1 minus R. So we just need to break the middle term in numerators. So R minus 2, R minus 1. We just need to take minus 1 common from denominator to make the cancellations. So by cancelling these two and by shifting minus here, we have 2 minus R, S, and this is what we had to show. Now, this is very important. Set of possible values S can take. Since S means sum to infinite, and sum to infinite only exists when R lies between these two, so by using this inequality, we can get the values of S. This is A part 2. As S infinite exists, so R lies between these two. Since S was 2 minus R, so we have R from this equation. It's 2 minus S. So by substituting R here, we can get the range of values of S. We just need to shift 2 on other sides of the inequality. So minus 3 and minus 1. When you will bring this 2 here, it will become minus 3. When you will bring this 2 here, it will become minus 1. Just a moment, please. See, this means S lies between 1 and 3. S lies between 1 and 3. So we can write the answer in this way. This is the required range of values of S. In this question, the most important thing is the range of values of R. And for sum to infinite, R lies between minus 1 and 1. This is important. A GP has, this question is simple, so I'm leaving this question. Part A. Each year the value of a certain rare stem increases by 5%. So R is 105%, which means 1.05. At the beginning of the year, a collector bought this stem for $10,000. So this is A. At the beginning of 2005, so the first year is 2005. Second year would be 2006, and the last year would be 2015. So if you would count these years, so this will become 11. 2015 means 11th year. 1, 2, 3, 4 till 2015 is 11. So the value of n for 2015 is 11. Now we need value in 2011. So we need T11. This value means T11. So T11 is AR to the power 10. So A is 10,000, I think. Yes. Whereas R is 1.05. Make sure you leave your answer up to 3 significant figures. The answer is $1,630. Second part, the Sn of an AP is this. Find the first term and the common difference. So part 2 of 10b. It's given Sn is n upon 2 and 3n plus 7. This is Sn. Yes. So for A, we need S1. N upon 2. So it's 1 upon 2, 10, because when we will put 1 here and here and here, we'll get this. So this is 5 and this is A. Remember, A is T1 and S1. This is A. If we have S1, that means A. Now, we need S2. For that, we need to put N2 here in this equation. So when we will put 2 here, we'll get 1, 2 here, 6 plus 7, 13. So we need T2. T2 is S2 minus S1. So 13 minus A, which is 5, 8. Now D is T2 minus T1. T2 is 8 and T1 is 5. So D is 3. We had to find two things, A and D. Well, this question is simple. I'm leaving this. Okay, I'm solving this question. 12. On a certain day, the height of a young bamboo plant was found to be 40 centimeter. So this is A. After exactly one day, its height was found to be 41.2. This is T2. So A is 40. First term is 40, second is 41.2. Two different models are used to predict the heights exactly 60 days after it was first measured. So exactly 60 days after it was first measured means 61. This means T61. Model A assumes that the height continues constant, means AP. So we need, for model A, which is AP, we need D. So D is 41.2 minus 40. So it's 1.2. Model B, percentage, that means GP. So for model B, we need R. So R is T2 upon T1. So 41.2 over 40, which is 1.03. Now, the question is, part 1, find the height after exactly 60 days. So we need T61. So A is 40, 60 times 1.2. This is part 1. Part 2, model B, find the height after exactly 60 days. So T61, according to GP, it's A R to the power 60. This answer is 112 and this answer is 236. Next question, 13. A GP has a second term 12 and a sum to infinity is 54. So this is very simple. T2 is 12. So AR is 12. And we need first term. So we need R in terms of A. And sum to infinite is 54. S infinite is 54. So A upon 1 minus R, and R is 1 minus 12 upon A. When we will solve this, we'll get two values of A, and those values of A are 36 and 18. Part B. The n term of a progression. Since in our syllabus only two progressions are there, AP and GP, and this structure is similar to AP. So this is the n term of AP. And Sn is the sum of the first n terms. We need expression of Sn. So this is Tn of AP and we need expression of Sn in terms of these letters. Tn is P plus Qn. So this is part B, 13 part B, given Tn is P plus Qn. Let me check this. Yes. So we need A and D. For A we need T1, P plus Q. This is A. And T2, P plus 2Q. So D is T2 minus T1. So T2 is P plus 2Q and T1 is P minus Q, like after substitution here. So D is Q. Now we need Sn. So Sn is n upon 2, 2a. A is P plus Q, so 2p, 2q. N minus 1 times Q. This is Sn. And the simplified form of Sn would be 2p plus Q plus NQ. So that's the answer of B part 1. Now, given that S4 is this, S6 is this, find the values of P and Q. We just need to make simultaneous equations with the help of this formula. So S4 is 40, I guess. Yes. And S6 is 72. I'm leaving this part for you. Just substitute this here and get the equation 1, substitute this here, get the equation 2 and solve them simultaneously. Question number 14. A company producing salt from seawater changed to a new process. The amount of salt obtained each week increased by 2%. So this is GP with with R 102%, which is 1.02. It is given that in the first week after the change, the company obtained this. This is the first term. Find the amount of salt in a particular week, which is T12. So T12 means T12. 12th week means T12. Total amount in the 12 weeks. So we need S12. So in the first part, we need T12, which is AR power 11. So 8000 times 1.02 power 11. Make sure you leave your answer up to 3 significant figures. Part 2, S12, it should be A times 1 minus R power 12 over 1 minus 1.02. And leave your answer up to 3 significant figures. Check this solution again, please. In the first part, we needed T12. In the second part, we needed S12. Question 15. The common ratio is 0.99. Express the sum of the first 100 terms, which is S100, as a percentage of the sum to infinity. That is S infinity times 100. So this is the requirement of this question. So S100 is A, 1 minus R, which is 0.99 power 100, 1 minus 0.99 divided by S infinity, which is A upon 1 minus R, is equal to, it's not equal to, it's 100 times, according to this. Now we just need to do cancellation. This, and this would be cancelled. So we have 1 minus 0.99 power 100 times 100. When you will solve this, you'll get 63%. It's mentioned 2 significant figures. That is why the answer I left as 2 significant figures, 63%. You can check the solution again. Leaving this question because this is a simple question. 17. The first three terms of an AP are 4, x and y. Since we have three consecutive terms, so we can use this formula of t to make the calculations easy. So x minus 4, y minus x. So by solving these two, we have 2x is y plus 4. This is the equation number 1. The first three terms of a GP are this, x, y and 18. So we have this formula of GP to make the calculation simple. So x, y, 18. So y upon x, 18 upon y. So by solving these two, we have y square is 18x. So this is equation number 2. And this is equation number 1. So by solving these two values of, equations, we can get the positive values of x and y. So by solving 1 and 2, we have x and y. So x is 8 and y is 17. X is 8 and y is 12. Now the second part of this question is find the fourth term of each progression. This is very simple. The first progression is AP and the second progression is GP. This is part 2. So fourth term means A plus 3D, and here fourth term means AR cube. So the first term of AP is 4 and x, the value of x is 8, I guess. So D is 4. 4 plus 3 into 4. So I think it's 16. So T4, A of GP is x, so 8, and y R is 18 upon y, and y is 12, so 3 upon 2. So this is the fourth term of the GP, and this is the fourth term of the AP. After getting the values of x and y, you can easily solve the last part. Question 18. In an AP, the first term is a, common difference is 3. And the nth term is 94. So Tn is 94. And Tn is a plus n minus 1d. D is 3. And the sum of the first n terms is 1420. So Sn is 1420. Sn is n upon 2, 2a plus n minus 1 d 1420. Well, we can write 2a as a plus a to make the substitution simple. See, this entire thing can be substituted by 94. So a plus 94. This is here. This entire thing is 94. Now find A from here so that we can substitute A here. So A is 94 minus n minus 1, 3. So we have n upon 2, 94 minus 3, n minus 1 plus 94. So when you will solve this equation, you will get the values of n, and you have to decide the right value of n. So n is 40. By the way, when you will simplify this equation, you will get this equation: 3n square minus 191n plus 2840. And when you will solve this equation with the help of quadratic formula, you will get two values of n. Since n is integer, so you have to take this value of n. And this is what we had to find. In this question, this step is important, the substitution step. Try to make the calculations or substitutions simple. Question number 19. The first and second terms of a GP are this and this. So R is 2P upon P, so it's 2. Where P is a positive constant, the sum of the first n terms is greater than 1000P. So Sn is greater than 1000P. We have to show this thing. So Sn is A, and which is P, 1 minus R, which is 2 power n. R is 2. 1 minus 2, 1000P. We can cancel these two P's. So we have 1 minus 2 power n over minus 1, 1000. Now bring this 1 here, minus 1 here. So we'll get 2 power n minus 1 greater than 1000. So 2 power n greater than 1001. This is what we had to show. You can check this solution again. Now the next part of this question. In another case, these are two terms of NAP, and the n term is 336. Sum of this, two equations in n, and solve this. This question is similar to 18, this one. So you can solve this question yourself. I'm leaving this question for you. 19 part 2, leaving a space as well. This would need 2 pages. Question number 20. The third and fourth terms of a GP are this. Find the sum to infinity. First part is simple, so I'm leaving the first part. Part B. Two schemes are proposed for increasing the amount of household waste that is recycled each week. Scheme A is to increase the amount of waste recycled by 0.16. So this is AP with D 0.16. Scheme B, percentage 6% increase. So R is 1.06. The proposal is to operate this scheme for a period of 24 months. So N is 24. For each scheme, N A is 2.5. Find the total amount of waste that would be recycled over 24 months. So we have this thing. A is 2.5, D is 0.16, and R is 1.06. So for both schemes, we need total amount of waste. So we need S24 in AP and in GP, in both. So for AP, S24, it should be 24 upon 2, 2A, A is 2.5, 23.16. Let me check this. Yes, it's 0.16. Leave your answer up to 3 significant figures. Now, S24 of GP, it should be A, which is 2.5, I think. Yes, and 1 minus R, which is 1.06 to the power 24 over 1 minus 1.06. Make sure you leave your answer up to 3 significant figures. Part A. In an AP, the sum of the first 10 terms is equal to the sum of the next 5 terms. This is very simple. Sum of the first 10 terms. Sum of the first 10 terms means S10. And sum of the next 5 means S15 minus S10. Because next 5 means 10 plus 5, which makes 15. So sum of the first 10 is equal to sum of the next 5. So this is a given. Check this here. Sum of the first 10 is equal to sum of the next 5. Find the first term. So this is very simple. First, we need to bring this on left hand side. So 2S10 is equal to S15. So S10 is 10 upon 2, 2A, 9D. S15 is 15 upon 2, 2A, 14D. Now we can cancel these two 2's. So we have 20, 2A plus 9D and 15, 2A plus 14D. The question is find the common difference. We have to show common difference. This is the common difference. So when we will solve this, we'll get D A upon 3. And this is what we had to show. Now the next part of this question. Given that the 10th term is 36 more than the 4th term, the 10th term is greater than the 4th term. And 10, when you will bring this here, 10 term is 36 more than, their difference is 36. And the question is, find the value of A. So 10 term means A plus 9D, 4 term means A plus 3D. So 90 minus 3D is 60. So D is 6. So A is, according to this equation, 18. Now the last part of this question. The sum to infinity of a GP is 9 times the sum of the first 4 terms. So this is very simple. Sum to infinity 9 times sum of the first 4 terms. Part B. the sum to infinity is 9 times sum of the first 4. So a upon 1 minus r 9, a 1 minus r power 4, 1 minus r. Now do the cancellation. A 1 minus r 1 minus r. So we have 1 is equal to 9, 1 minus r power 4. So when you will solve this, you will get the value of r, which is r power 4 8 upon 9. Or you can say r is eight upon 9 root index 4. Given that the first term is 12, find the value of the fifth term. First term is 12. It's here. We need t fifth. So t fifth is 12 times ar4. T fifth is a times r4. ar to the power 4. So 12 into 8 upon 9, which is 3, 4, 8, 32 upon 3. You don't need to do this because you needed a power 4. This was 21 part B. Now the next question. Two heavyweight boxers decide that they would be more successful if they competed in a lower weight class. For each boxer, this would require a total weight loss of 13 kg. So SN is 13. At the end of week 1, they have each recorded a weight loss of 1 kg. So this is A. And they both find that in each of the following weeks, their weight loss is slightly less than the week before. So decreasing sequence. Boxer A's weight loss in week 2 is 0.98. It is given that his weekly weight loss follows an AP. So for boxer A, the sequence is AP and the first term is 1 and the second term is 0.98. So D is minus 0.02. Write down an expression for his total weight loss after X weeks. So this is very simple. So N is X in part 1, so we need Sx. It's X upon 2, 2 into 1 because A is 1, X minus 1, D is minus 0.02. So that's the answer of part 1. Now, part 2, he reaches his 13 kg target during N week. Find the value of N. So, very simple. We just need to equate this with 13. And we can replace X by N as well. Or you can leave X as it is. 2 minus 0.02, X minus 1. When we will solve this equation, we will get the value of X. The simplified form of this equation is 0.02 x square, 2.02 x plus 26. When you will use quadratic formula, you will get two values of x, 85.6 or 16.1. Now you have to decide which value is right. So we just need to find T13. So T13 of the first one, I mean the integer value of this should be 16. So we just need to find T16. If this is positive, then this value is right. And this is 86. And when you will find 86, this will be negative. So this is discarded and this is the right answer. Since both values are positive, so we have to check our answers. With this, his weight is positive, and with this, his weight is negative, which is not possible. Negative weight is not possible. So this is the right answer. Now, the second part of this question. Third part. Boxer B's weight loss in week 2 is this, and it follows a geometric. His total weight loss after 20 weeks. So we need S20. S20. So A is 1 and R is second term is 0.92. So R is T2 upon T1, 0.92. So 1 minus 0.92 power 20 over 1 minus 0.92. So S20 is, you have to check this yourself, S20. Now, the last part, and show that he can never reach his target. This means S infinite. And S infinite must be less than his target, which is 13. He can never reach his target means S infinite must be less than his target. We have to show this. To show S infinite less than 13 in the last part of this question. So A 1 minus R. When you will calculate this, you will get 12.5. And this is what we had to show. 12.5 is less than his target.